Hey everyone, I'm Emma from CybrBrief, and today we're diving into the world of switch security like never before. Switches are the unsung heroes of our networks, managing where data goes, but they can also be the Achilles heel if not properly secured. Let's get into 5 common switch attacks and explore how you can become an expert in defending against them. First up, VLAN hopping. Imagine your network as a city with different neighborhoods, or VLANs, where each has its own unique traffic rules. VLAN hopping is like finding a secret path from one neighborhood to another where you're not supposed to go. Attackers can manipulate network packets to bypass these boundaries, accessing areas of your network they shouldn't. To stop this, you need to lock down your VLANs. Use VLAN Access Control List or VACLs to control what traffic can move between VLANs. Also, make sure your trunk ports are secure, preventing them from leaking VLAN information. Double tagging attacks are a common method here, where an attacker crafts packets to jump VLANs, so we use techniques like VLAN trunking protocol or VTP pruning to minimize this risk. But let's dive deeper. VLAN hopping can be achieved through several methods. For instance, switch spoofing happens when an attacker configures a device to mimic a switch and sends dynamic trunking protocol or DTP frames to negotiate a trunk link, allowing access to all VLANs. You can mitigate this by disabling DTP on ports not intended for trunking. Another technique is double tagging, where an attacker crafts packets with two IEEE 802.1Q tags. The first tag is stripped by the first switch, but the second allows the packet to hop into another VLAN. Ensuring that trunk ports are not set to accept double-tagged frames can prevent this. Then there's VTP manipulation. If an attacker gets into your VTP domain, they can manipulate VLAN configurations across all switches. Running VTP in transparent mode or securing it with passwords can limit this risk. To counter these, disable unused ports to reduce potential entry points for attackers. Use port security to limit which media access control or MAC addresses can use a port, making it harder to negotiate trunks and helping to identify unauthorized devices. Deploy VTP in transparent mode to prevent changes from propagating, reducing the risk if an attacker compromises one switch. Implement VLAN ACLs to restrict traffic moving between VLANs, adding another layer of security. Use private VLANs in environments where some users or devices should not communicate directly, isolating traffic within the same VLAN. Network Access Control, or NAC, ensures devices meet security policies before they can hop VLANs. Enable Layer 2 security features like IEEE 802.1X for port-based authentication to ensure only authorized devices can connect. Next, let's talk about Spanning Tree Protocol, or STP manipulation. STP is like the traffic police of your network, ensuring data doesn't get stuck in endless loops. But if attackers can manipulate these police officers, they can cause chaos or even direct traffic their way. By impersonating STP messages, attackers can create loops, leading to a denial of service or DOS, or reconfigure switches for man-in-the-middle attacks. To defend against this, enable Bridge Protocol Data Unit or BPDU guard on user ports to prevent rogue STP messages. Also implement Root Guard to stop unauthorized devices from becoming the root of the network, which could disrupt STP's normal operation. Let's explore further. BPDU flooding is when an attacker floods the network with BPU messages, confusing the STP process. BPDU filtering can mitigate this by dropping these messages. Root bridge hijacking occurs when an attacker configures their device to have the lowest bridge ID, making it the root bridge and controlling traffic flow. Root Guard can prevent this by blocking ports attempting to become the root bridge from an unauthorized switch. Defensive measures include using Loop Guard to ensure that a non-designated port does not become a designated port, preventing loops by keeping the port in blocking state if it stops receiving BPDUs. Uplink Fast speeds up recovery from direct link failure by avoiding the listening and learning states, which can be crucial in preventing network downtime. Backbone Fast helps recover faster from indirect failures by bypassing unnecessary STP states, reducing the time to reconfigure paths. Port Fast is used on access ports to bypass the listening and learning phases, speeding up device connectivity, but should be used carefully to avoid STP issues. BPDU Guard with Air Disable automatically disables ports receiving BPUs, which is useful if someone plugs in an unauthorized switch. BPDU protection prevents STP from being manipulated by ensuring BPUs are only accepted from authorized devices. Storm Control protects against BPDU storms by limiting the number of BPDUs that can be received on a port. Now, on to MAC flooding. Every device on your network has a unique MAC address, like a social security number for network devices. In a MAC flooding attack, attackers send a flood of fake MAC addresses to the switch, overwhelming its memory. When the switch can't remember who's who, it might just start broadcasting all data to everyone, turning it into a security sieve. Port security is your friend here. Limit the number of MAC addresses per port or set up dynamic port security to automatically lock down a port if too many new MAC addresses appear. Also, consider using storm control to prevent broadcast storms and keep an eye out for sudden spikes in MAC address registrations. But there's more. Content Addressable Memory or CAM table. Overflow happens when the CAM table where the switch stores MAC addresses gets overloaded, leading to broadcast behavior. Address Resolution Protocol or ARP cache poisoning can be combined with MAC flooding to redirect traffic by changing MAC to IP mappings. Defenses include static MAC address assignment, where you manually configure which MAC addresses are allowed on specific ports, preventing unauthorized devices from connecting. MAC address notification alerts when a new MAC address is detected, allowing for quick response or investigation. Use of VLANs can limit the spread of traffic even if a switch reverts to broadcasting, containing the damage. Sticky MAC addresses automatically learn and apply MAC addresses to port security, but with administrative control to prevent unauthorized learning. Rate limiting controls the amount of traffic on a port to prevent overwhelming the switch with MAC address updates. MAC move detection monitors for MAC addresses moving around the network unexpectedly, which could indicate an attack. Dynamic Host Configuration Protocol, or DHCP, snooping binding ensures that MAC addresses are only associated with the IP addresses they've been allocated. Let's shift gears to DHCP manipulation. DHCP is the network's welcome committee, giving out IP addresses and other essential settings to devices as they join. But what if an attacker decides to host this welcome party? They could intercept these settings, redirecting all your traffic through their device. DHCP snooping is key here. It ensures only authorized servers can hand out IP addresses. Combine this with dynamic ARP inspection or DAI to verify each device's identity before allowing them on the network. Also, IP Source Guard can prevent devices from using IP addresses they weren't assigned, stopping attackers from masquerading as legitimate devices. Let's expand. A rogue DHCP server is when an attacker sets up a fake DHCP server to distribute incorrect network settings, possibly redirecting traffic. DHCP snooping can filter out these rogue responses. DHCP starvation involves overloading the DHCP server with requests to exhaust its address pool, which can be countered with DHCP snooping and rate limiting. Defensive measures include DHCP snooping to filter untrusted DHCP messages, ensuring only the real DHCP server's responses are accepted. Rate limiting controls how many DHCP requests can be made in a given time period to prevent starvation attacks. DHCP Relay centralizes DHCP requests through a trusted relay agent, reducing the attack surface. Lease duration management shortens lease times, making starvation attacks more difficult to sustain. Binding integrity ensures that the IP address, MAC address, and port number combinations are consistent. Dynamic ARP inspection, or DAI, works with DHCP snooping to validate ARP packets in the network. IP Source Guard enforces IP MAC address binding to prevent IP spoofing on untrusted ports. Last but not least, CDP or Cisco Discovery Protocol. This is like the network's gossip protocol, sharing details about who's who and what's what among devices. But when this gossip falls into the wrong hands, it can lead to targeted attacks, as attackers learn about switch models, operating system or OS versions, and even admin logins. To protect this information, restrict CDP broadcasts to only where they're needed, like between management interfaces. Consider disabling CDP on ports where it's not necessary or encrypting this information if possible. Use private VLANs to further isolate traffic, reducing the amount of visible network information. Digging deeper, CDP spoofing is when an attacker can impersonate network devices to gather or spread false information. Disabling CDP on user-facing ports can mitigate this. CDP reconnaissance involves gathering network topology for planning attacks. Limit where CDP messages can travel to reduce this exposure. Countermeasures include disabling CDP on user ports to prevent unnecessary information leakage. Limit CDP to management VLANs to restrict where this information can go, making it harder for attackers to gather network details. Use Link Layer Discovery Protocol, or LLDP, instead, which might offer more control over what information is shared and can be configured to be more secure. Network Access Control, or NAC, combines with CDP to ensure only devices meeting security policies can access network information. Encryption of discovery protocols, where possible, encrypts CDP or uses alternatives that offer encryption. Regular security audits check for misconfigurations or unnecessary exposure of CDP information. But protecting your switches isn't just about individual defenses. Regular audits keep checking your network's configuration to ensure no vulnerabilities are creeping in, including reviewing switch settings, access controls, and security policies. Network monitoring uses tools to detect unusual patterns or behaviors on your network, looking for anomalies like unexpected traffic patterns or unauthorized VLAN mappings. Education trains your team to recognize these threats. They're your first line of defense. Regular security awareness sessions can highlight the importance of switch security. Segmentation keeps high-value assets in separate network segments for added protection, applying not just to VLANs but to physical network isolation as well. Stay updated by keeping your switch firmware up to date to close known security holes. Manufacturers often release patches for vulnerabilities that could be exploited in these attacks. Physical security matters too. Even the best digital defenses can be bypassed with physical access. Secure access to your switch rooms and control who can physically interact with your network infrastructure. Red teaming simulates attacks on your network to see how well your defenses hold up, uncovering weaknesses in your switch configurations or policies. Incident response planning prepares you for when attacks happen, knowing how to isolate affected areas, recover, and learn from each incident to improve your security posture. Network design starts with security in mind, considering switch placement, network flow, and redundancy. Security Information and Event Management, or SIEM systems, give you a complete view of network events, correlating logs from switches with other network devices. Keep an eye on vendor security advisories to stay ahead of new threats or vulnerabilities related to your switch models. Remember, the cybersecurity landscape shifts like sand dunes. Today's defense might be tomorrow's vulnerability, so continuous learning and adaptation are crucial. If you're digging this deep dive into switch security, stick around for more. I've got loads of content coming that'll keep you on your toes. Whether you're a pro or just starting, we're in this together, making you an expert in cybersecurity, one episode at a time. Don't forget to like, subscribe, and ring that bell for more cyber adventures. Until next time, keep learning, keep questioning, and stay secure, my friends.